are back with another state test review. We're on the standard 7.SP.6, our sixth statistics and probability standard. Let's hop right in. Question 1, Joe designs a weighted number generator that produces the integers 0 to 4. He then runs the generator 500 times. The results are shown in the table. If Joe runs the generator a total of 4,000 times, which is closest to the number of expected times the integer 4 will be produced. So, we know that's ran 500 times. And that integer 4 came up 152 times. Now, what you could do is you could figure out what percent of 500 152 is, and then multiply that by 4,000 to get the answer. Or, hear me out on this, you could say this is a ratio. So if you got it 152 out of 500 times, and then you want to see what this is 4,000 times, to go from 500 to 4,000 by multiplying, you multiply by 8. So for this answer, all you have to do is multiply 152 by 8. Calculator, please. 152 times 8. And that gives you 1,216. Which of these answers is closest? D. Question 2. A six-sided number cube with sides labeled 1, 2, 3, 4, 5, and 6 is rolled 50 times. What's a good prediction for the number of times a 50 will be rolled? No calculator. Okay. So, you have 6 possible options. Okay. 1, 2, 3, 4, 5, and 6. So you have a 1 out of 6 chance. Okay? So the question is, what is a good prediction for how many times you'll roll the 5 in 50 attempts? Okay? So you have a 1 out of 6 chance 50 times. Remember to multiply a fraction by a whole number. You put the whole number over 1, multiply across. 50 divided by 6. So now we have to do 60 divided by 50. 6 doesn't go into 5, but 6 does go into 50 8 times. 6 times 8 is 48. We're not done, so we add a decimal and drop it down. 6 goes into 20 3 times. At this point, I'd stop. Because you're looking for a good prediction for the amount of times the 5 will be rolled. So you want a whole number and 1 decimal to use to round the whole number. Okay? So we have the whole number of 8. We have 1 decimal place of 3 that we could use to round the 8 up or down. Remember, 5 and above, give it a shove. 4 and below, I don't have a fun rhyme for that, but you keep it low. Ooh, 4 and below, keep it low. There you go, we did it, on the fly. So with a 3, that's going to round down. So it's going to leave us at 8. Is a good prediction for the amount of times a 5 will be rolled. Oh, that was it. Well, I guess we're done with that standard already. No, let's just squeeze. Let's just do 6 and 7 in the same video. 6, 7. And go right into number 7. Mr. Larkin grouped the students in his class into 4 groups of equal size labeled red, blue, green, and yellow. Each day, Mr. Larkin selects one group at random to read aloud during class. The groups selected each day for 8 days are shown. Green, blue, red, blue, blue, blue. Notice that yellow has never been picked. Which group's observed frequency of being selected is closest to the expected frequency? So, there are 4 groups. So everyone's chance of being picked is 1 out of 4. Okay? If you roll it 8 times, to go from 4 to 8, you can multiply by 2. which means we would multiply our 1 by 2 for 2. So, if you rolled this 1 out of 4 chance 8 times, you would expect to have your group picked twice. So we have red, blue, green, yellow. Green is picked twice. Blue is picked 1, 2, 3, 4, 5 times. Red is picked once, and yellow is never picked. So the groups with the observed frequency of 2 times out of 8 chances, as closest to its expected frequency of 2 times out of 8 chances, will be the green group. Question 2, no calculator. Zane has a bag filled with coins. The bag contains 7 quarters, 8 dimes, 3 nickels, 9 pennies. He randomly chooses a coin from the bag. What is the probability that he chooses a quarter or a nickel? Okay, so first we have to add up how many possible options we have. We have 7, 8, 3, and 9. Okay, that's how many coins are in the bag. 7 plus 8 is 15. 15 plus 3 is 18. 18 plus 9 is 27. There are 27 total coins in the bag. Okay? We need the probability that he'll choose a quarter or a nickel. There are 7 quarters. There are 3 nickels. 7 plus 3 is 10. So his odds of pulling a quarter or a nickel are 10 out of 27. There are 10 coins he can pull out of 27 possible options. Question 3. A gumball machine contains equal numbers of red, yellow, green, and blue gumballs. Equal is important. It randomly gives out 1 gumball for each pull at the machine. What is the probability of getting a red or green? So, red, yellow, green, blue. There's 4 different colors, so your odds of pulling any particular color, because they are equal odds, is 1 out of 4. 1 out of 4. So to pull a red or a green would be 1 out of 1 out of 4 plus 1 out of 4 to give you 2 out of 4. So your probability is 2 out of 4, or 1/2, or 50%. Simple as that. Question 4. Factory produces 80,000 candles every day. They produce equal quantities of 4 flavors. Again, equal. Big word. Cherry, lemon, orange, and strawberry. The candles are mixed together during packaging. What is the probability that a randomly selected candy is orange? I said candles. I was wondering why there were flavors of candles. Okay, so this question is far more simpler than it seems. The fact that they make 80,000 candies, not relevant. What's relevant is that you have 4 flavors and there's equal quantities. So every flavor has a 1 in 4 chance of appearing. So if you're looking for one color, which is orange, which is one of the 4 flavors, then the probability is 1 out of 4. Question 5. A bag contains 25 cookies. There are 15 chocolate chip cookies, 7 peanut butter cookies, and the rest are oatmeal raisin cookies. What is the probability of choosing a chocolate chip or peanut butter? So, we know there are 25 cookies. How many chocolate chip are there? 15. How many peanut butter are there? 7. So how many chocolate chip or peanut butter cookies are there? 15 plus 7. 5 plus 7 is 12. Carry the 1. 1 plus 1 is 2. So you have 22 possible cookies out of a total of 25. That's it. There's no simplifying required. You just put how many possible options, how many are good out of the total. Question 6. The letter tiles here are placed in a bowl. Matt selects one tile from the bowl. What is the possibility that he will select one of the letters in the word jump? Okay, so we see that there are no repeat letters here. We have J, we have M, we have P, we have U. That means that there are 4, count it, 4 good options out of how many total options? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 4 good options out of 10 possible options. So the probability is 4 out of 10. Question 7. This item has 3 parts. There are 23 students in Mr. Wilson's class. Mr. Wilson wants to determine the probabilities of male and female students playing on a school sports team. He surveyed his students and determined the following. There are more males than females in this class. Fewer males than females in Mr. Wilson's class are on a sports team. The majority of females in Mr. Wilson's class are not on a sports team. So, they don't give you exact numbers here. They give you clues. There are more males than females in Mr. Wilson's class. Excuse me one second. I'm going to pause the recording for a second because I want to make sure I'm understanding this question right before I give an answer. Okay, we're back. So there are multiple correct answers for this. This is potentially worth 3 points, and 3 points is a lot when we talk about where you're going to get your 15 or where you're going to get your 24 raw score. Okay? So let's take this question seriously. To get all 3 points on here, we have to satisfy 3 rules. There are more males than females in Mr. Wilson's class. Okay. So your total males needs to be bigger than your total females. It needs to add up to 23. Let's say 13 males, 10 females. That satisfies rule 1, that there are more males than females. Fewer males than females in Mr. Wilson's class are on a school sports team. Okay? So let's say that 1 male is on a sports team. 2 females are on a sports team. Rule satisfied. The majority of females in Mr. Wilson's class are not on a school sports team. Great. That means that this needs to be smaller than this. We have 10 total females. 2 of them play on a sports team. That means 8 do not. We have 13 total males. 1 plays on a sports team, which means 12 do not. Then we have 1 male and 2 females that play on sports teams. That means 3 people total do. And 12 and 8 don't, which makes 20. And these both add up to 23, so you know you're good. What is the exact probability that a female chosen at random plays on a school sports team? So, a female. You're working with a female. You have 10 possible females. The odds that they play on a school sports team is 2 out of 10. Part C. What is the exact probability that a student chosen at random, a student, so this could be anyone out of the 23, is a male that does not play a sport? So a male that does not play a sport. That is a subsection of 12. 12 out of 23. And that's a two-way table. Two-way tables will show up in 7th grade, 8th grade, even Algebra 1. So it's a good thing to learn how to work a two-way table now. Question 8. Kara's teacher divides her class of 20 students into 4 equally sized teams, red, yellow, green, and blue. She assigns each to a team. Okay, so there are 20 students. Okay. What is the probability that Kara is on the red team? How many options are there? There are 4 options. No, I was right. 20 total students, 4 possible options. That means there is a 4 out of 20 chance. Or if you simplify it, if you divide both of these by 4, we get 1 out of 5, which makes sense because 20 divided by 4 is 5. What am I doing? Okay. I'm going to ask for grace here. Because it is almost 9 o'clock at night. I've been doing this for a while. And I just went against everything I said in the previous questions. So let's go back. We're not unable to make a mistake. Let's go back. Kara's teacher divides her class into 20 students. This is not relevant. Into 4 equally sized teams. What is the probability that she is on the red team? There is 1 good scenario where she's on the red team out of 4 possible teams. 1/4. That's it. Don't overthink it, like I just did. 1 scenario, 1 winning scenario where she gets on the red team out of the 4 possible teams. Oh my goodness. Question 9. The 25 students in Jason's class have a choice of 3 extracurricular activities. Of this total number of students, 8 choose soccer, 6 choose math club, and the rest choose chorus. What is the probability that Jason chooses chorus? Okay, so there's 25 students. Out of those 25 students, 8 of them chose soccer, and 6 of them chose math club. 8 plus 6 is 14. That means if you take those 14 students out of the 25, you're left with 11. Those 11, the rest, chose chorus. So his probability of choosing chorus is 11 out of 25. Question 10. No calculator. A bag containing red, blue, yellow, green, and purple marbles, all of which are the same size. The probability of selecting a single marble for 2 of the colors is shown in the table. The probability of selecting a red or yellow marble is 5/16. The probability of selecting a green marble is twice the probability of selecting a yellow marble. What is the probability of selecting a green marble? All right, so the probability of selecting a red or yellow marble is 5/16. We know that the probability of selecting a red marble is 2/16, which means that the remaining part of that is 3/16, because 5 minus 2 is 3. So the probability of choosing a yellow marble is 3/16. The probability of selecting a green marble is twice the probability of selecting a yellow marble. So we take the 3/16 of the yellow marble and multiply it by 2. 2 over 1. 3 times 2 is 6. 16 times 1 is 16. So your probability of choosing a green marble is 6 out of 16. That's your answer. What's the probability of choosing a purple marble? Not relevant. For the record, it's 3 out of 16, but it's not relevant. Question 11. There are 30 students in Rockham's math class. The teacher randomly selects students one at a time to go to the board to complete a problem. The teacher selects each student only once. Rockham is not selected for the first 5 problems. What is the probability he will go to the board next? So there are 30 students. 5 people have already been chosen. That leaves 25 people left. So out of the 25 remaining people, Rockham represents one of them. So it is a 1 out of 25 shot. Again, the number of possible winning options out of the total number of options. Damien has a bag of pencils. Each pencil has a color and a pattern. There are an equal number of pencils of each color and pattern. The colors are red, blue, green, yellow, and orange. The patterns are solid, checkered, and striped. Damien picks a pencil from the bag. What is the probability? He picks a solid yellow pencil. So let's think about this. Okay, we have 3 patterns. We have solid, checkered, and striped. So for red, there is red, solid, red, checkered, red, striped. Then you have blue, solid, blue, checkered, blue, striped. Then you have green, solid, green, checkered, green, striped. Then you have yellow, solid, yellow, checkered, yellow, striped. And finally, you have orange, solid, orange, checkered, orange, striped. So you have 15 possible options. The odds of pulling exactly the solid yellow pencil is 1 out of 15. You could have gotten how many possible options there are by taking the amount of colors, of which there are 5, and multiplying it by the amount of patterns, of which there are 3, for 15 possible combinations. Or you can list them all out like that. Either way works. All right, question 13. Jared practices batting. In the first 5 pitches, he hits the ball 2 times. Based on the first 5 pitches, what is the probability he will miss the next pitch? All right, so Jared, in 5 pitches, he hits twice. If he's not hitting, he's missing. So the amount of times he misses is 1 minus 2.5, or I'm sorry, 2 over 5, or otherwise known as what's left over, which is 3 out of 5. So based on the first 5 pitches, if you pick a random pitch, the odds that he'll miss the next pitch is 3 out of 5. Take how much he hits, whatever's left over is what he misses. If 2 out of 5 hit, that means he has 3 out of 5 left to miss. He will miss 3 out of 5. So that does it for this standard. If you're watching in chronological order or if you're watching in page order, 1 standard to go. Let's get it done. Until then, I'll see. Thank you for watching and good luck on the tests.